All right, Mr. Ahmed here to teach you another method today to solve quadratics, and we are going to use square roots. And this is 9.3. So the process for this one is going to be us solving a quadratic, which is an x squared type equation that does not have a middle term. So there's not going to be an x. We are just going to have an x squared for the first type. The second type would involve when we have a value being squared that's inside of a set of parentheses, so a sum or a difference, and we can isolate that. So a couple things here. The reason why we can solve using square roots is because the opposite of squaring something is to take the square root. Those are inverse operations of one another. So that allows me to isolate the x and solve the equation, okay? So what we're gonna do is we're gonna isolate the x squared. Now I can't do this if there's an x squared and an x, okay? It can just be an x squared. So the equation just needs to say something like x squared minus 20 equals 0. So there's no middle term with an x. All right, if there's an x, we're going to have to use a different method. We'll either have to factor or we could use the quadratic formula. So in this case, there's just an x squared and a constant. All right, what we're going to do is we're going to get the x squared alone, and then we are going to square root both sides. Now, the key here is when I take the square root, I have to include both the positive and the negative value. The reason behind that is because there's two ways that I could get to 9. I could get to that by taking 3 squared, or I could also take negative 3 squared. They're both equal to 9. All right. After that, we're going to simplify the radical and we will be done. So, first example is x squared equals 50. In this case, x squared is already isolated. Once it's isolated, for me to undo the squared, I can take the square root. That cancels off the squared. If I do it to one side, I have to do it to the other side. All right? Now, the key, when I insert the square root into an equation, when I put it there, it needs to be both the positive or the negative value. So x is equal to plus or minus the square root of 50, because it could be both the positive or the negative value that is going to make this true. All right? So when I solve this, again, I'm looking for the perfect square factors, 25 times 2. So x is equal to plus or minus the square root of 25 times the square root of 2. 25 times 2 is 50, just like the other day. We can then take the square root of 25, which is 5. So x is equal to plus or minus 5 times the square root of 2, which would be our two solutions. Or you could type that in and get the decimal values. This next one here is a little bit nicer because it's a 49. So I'm going to insert the square root onto both sides to cancel out the squared. So x is equal to plus or minus the square root of 49. Now, that's a perfect square. So my two solutions, x equals positive and negative 7. Now we can talk about this one a little bit easier because it makes more sense. If I put 7 back in, 7 squared is 49. That's one of the solutions. Negative 7 also works because negative 7 times negative 7 is also positive 49. So that's where we're getting our two solutions from. This next one here does not currently have the x squared isolated, so we're going to follow our same process as if we were solving equations. To undo multiplication, we would divide both sides by 5. After I divide by 5, I get x squared equals 25. I then insert the square root to both sides. When I put it there, it needs to be both the plus or the minus. And I can take the square root of 25, which is 5. So x is equal to plus and minus 5, positive and negative 5. A little bit tougher here. I got to get the x squared alone. There's no x term. So I can move the 22 by adding 22 to both sides. So I got 2x squared equals 64. I then divide both sides by 2. And we get x squared equals 32. All right, that one's not a perfect square. So when I take the square root, I'm going to have to simplify it. The perfect square factor that goes into 32 is 16. So x is equal to plus or minus the square root of 16 times the square root of 2. We can then take the square root of 16 to get plus or minus 4 times the square root of 2 is equal to x. We found our two solutions, both the positive and the negative. The next case is in vertex form, which was what I was talking about. We're going to have a sum or a difference inside of a set of parentheses. The reason why if it's in vertex form is I can undo the squared by taking the square root here. So that just makes it a little bit easier to solve. So we're going to get that squared value by itself first. Instead of just an x, it's going to be x minus or x plus something. We are then going to square root both sides, and then we're going to solve. So we're going to have to do two solutions. We cannot forget the plus or the minus. So our first example here. This value, the parentheses, the squared is by itself. So step one's complete. I can then take the square root of both sides. Now the key here is x plus 3 is equal to both positive and negative times the square root of 8. All right. I am then going to simplify the square root of 8, and then I'm going to subtract 3 from both sides to solve. So the square root of 8, 4 is the perfect square factor, so we have plus or minus square root 4 times square root of 2 equals x plus 3. We can simplify the square root of 4 to a 2, so it's plus or minus 2 times the square root of 2. I then need to keep my x plus 3 with. My equal sign is still there. To solve for x, I subtract 3 from both sides. The way I'm going to write this is with the number first. X is equal to negative 3 plus or minus 2 times the square root of 2 would be our exact form. You could type that into your calculator both ways to get the two decimals, which I'm going to on this one. And the way I would just type that in is exactly as it reads. So I have negative 3 plus 2 times the square root of 2. Enter. This calculator keeps this in perfect radical form. For me to get the decimal, I just have to push the 2 arrow button down at the bottom, and I get negative 0.17. And if I do it the other way, with the minus sign, so I'd have negative 3 minus 2 times the square root of 2, I would get a decimal approximation of negative 5.83. So those would be the two solutions rounded. We'd have to use a calculator to get that. All right, next one. I'm going to get a nicer number this time. To isolate the parentheses, first thing I need to do is divide both sides by 3 since it's being multiplied. So I can divide that. I can't distribute it because I would have to follow the order of operations and square it first. So I'm going to divide by 3, and I get x plus 1 squared is equal to 4. Now I can take the square root of both sides. Don't forget the plus or minus. Squared, square roots cancel, and I have x plus 1 equals plus or minus the square root of 4, which is 2. To solve, I will subtract 1 from both sides, and I would get x to equal negative 1 plus or minus 2. Now I'm going to find the two solutions. I have to do negative 1 plus 2, which is 1, and then negative 1 minus 2, which is negative 3. So those are my two solutions. Go ahead and hit pause and give the U-tries a run. All right, hopefully you had some success here. This one just has an x squared. There's no parentheses, so I'm going to isolate the x squared. First step is to subtract 4. 2x squared equals 40. Divide 2, x squared is equal to 20. And then we got to take the square root, plus and the minus. All right, 20. The perfect square factor is 4, so x is equal to plus or minus the square root of 4 times the square root of 5. I can then take the square root of 4, which is 2, times the square root of 5 equals x. Okay, last one. This one has the set of parentheses, so I am going to take the square root right away. Don't forget the plus or minus, so we get 2x plus 1 equals plus or minus 6. Now I have to solve this both ways. This one's a little bit tougher here. I can't just subtract the 1, divide by 2. I'm going to do this in two separate steps. 2x plus 1 equals 6, and 2x plus 1 equals negative 6. Now I can solve both equations. So subtract 1, 2x equals 5, divide 2, x equals 5 over 2, which is 2.5. That's our first solution. Going the other way. Subtract 1, 2x equals negative 7. Divide 2, X is equal to negative 7 over 2, which is also negative 3.5. And we got them. All right, that's it for today. Have a good one.